Okay, in problem 7, we have a manufacturing problem. It says the factory produces 100 chairs and it costs them $2,800. Then on another day they produce 300 chairs and it costs them $4,800. Find the cost function. So to do this, we're going to use slope formula. Slope formula says take the second y value minus the first y value divided by the second x value minus the first x value. So we need the slope of this linear curve. The second y value would be the $4,800. The first y value would be the $2,800. Now the x's are the chairs produced for those monies. So they produced 300 chairs for $4,800 and they produced 100 chairs for $2,800, and they give us nice numbers. This is $2,000 per 100 chairs, and so we get it costs roughly $20. No, 200 chairs, 300 minus 100. So it's going to cost $10 per chair. That's the slope. Okay, now we just got to plug this into the equation of a line, y equals mx plus b. And we can use either point, so let's use the easier point. $2,800 is $10 per chair times they made 100 chairs that day, plus b. So we get 2,800 equals 1,000, and the units on this would be dollars. The 10 has units of dollars per chair, and the 100 has units of chairs. The chairs would cancel, you're left with dollars, plus b. Subtract 1,000 from both sides. It is $1,800 for the b. Now the cost function is going to be the $10 per chair, so 10x, and then this is what's called a fixed cost of $1,800. So we call this one the variable cost because it varies depending on how many chairs you produce. And then this one's called the fixed cost. So this is like the cost of your factory, the cost of your workers, the cost of the material, fixed cost. That doesn't change. So it's $1,800. It doesn't matter if you produce 10 chairs or 1,000 chairs. Okay, so the only graph that's going to make sense is right here. When x is 0, no chairs produced, they still have a cost of $1,800. And then it has a slope of $10. So this is going up by 10, up by 10, up by 10, and over by 1, or however many they jump over by. So it has to be this graph here. But let's type in some of this stuff. So we would have the cost is 10x plus 1,800. I hope they don't want me to use dollar signs, but we'll see. If they do, they'll yell at me. This is the graph we picked. What is the slope of the graph? The slope of the graph is 10. What does it represent? So I mentioned this. It represents the variable costs. So it represents time, it represents cost of producing each. Yeah. So it represents the cost of producing each additional chair. So every chair you make adds a $10 cost to the equation. The y-intercept, 1,800. What does that represent? That represents the fixed cost. Okay, so in this case, the context, the only one I have to choose from is represents the fixed daily cost of operating the factory. So electricity, employees, material, all that sort of stuff. Okay, got that one completely right. Perfect. Okay, problem 8. Okay, problem 8 is really a trig review problem. And so we have to remember the basic graphs, sine and cosine. So let's start with sine curve. And the sine, let's see here. Sine curve varies between 1 and minus 1. And it goes between 0 and 2 pi. So this would be pi, and this would be pi over 2. 90 degrees, 180 degrees. 270 degrees is 3 pi over 2. and 2 pi. And what the curve does is it starts at 0, goes to 1, goes back to 0, down to -1, back to 0. Okay, so it's a pretty simple curve. Now that is the equation for sine x. Now what happens when I have a number in front of the x? Well, the period, which is one full cycle of this curve, when I don't have a number in front, the period is 2 pi. The easiest way to do a transformation with a number in front is to use this equation. So period equals 2 pi over omega. And omega is the angular rate, which is the number in front of the x value. So the period in this new one, so if I have y equals the sine of 1/8 x, this 1/8 is omega. So the new period is 2 pi over omega, which is 1/8, which is going to flip. So when you have a number divided by a fraction, the fraction flips, and this would become 8 times 2, which would be 16 pi. So the graph's going to look exactly the same, except for now these four numbers go to 16 pi, halfway would be 8 pi, half of that would be 4 pi, and in between these two would be 12 pi. And it's still going to bounce between -1 and 1. So the sine curve is going to start at 0, go to 1, back to 0, -1, back to 0. The only thing that changes is the scale. And if I look closely, the only one that matches it with the right scale is this one right here. So it goes from 0 to 1, down to 0 again, and that occurred between 0, 4 pi, and 8 pi. And then they just didn't show the rest of the curve because of the scale would get, I guess, too big. So that would be a basic sine curve. Okay, this one's real simple. Problem 9. We have to recall what absolute value function looks like in a graph. So in a graph, the absolute value function is really simple. It's a V. So it comes down at 45 degrees, goes up at 45 degrees. This is y equals the absolute value of x. Now what happens when you plug a number in here is this is just going to shift that curve on top 9 units, and it's counterintuitive, to the right. So the new 0 point is not at the origin. The new 0 point is at +9. So it's still going to look like a V, but it's going to come down to 9 and then go up like that. So the only one that makes sense is the first one. Okay, I also think it's useful to look at the wrong answers here. So let me explain what each of these would be. So this one would have been y equals x plus 9. So notice the plus makes it go to the left, over to -9. This one would have been y equals the absolute value of x with the -9 on the outside. So when the number's in with the absolute value, it shifts it left or right. When the number's outside of the absolute value, it goes up or down. So this one would be y is equal to absolute value of x plus 9. So those are all four possibilities you could see. Now there's more transformations than that, but those are the only translational transformations, left, right, up, or down. Okay, 10 are called composite functions, and they tend to give students issue, I see a lot of times. So when you see FOG, this is called a composite function. And what it means is you're composing a new function based on other functions. So oftentimes what you do is you take a function and plug it into another function. Okay, so if we have f of g, that is really taking the g function and placing it into the f function. So we're going to take the x value of x and replace it with all of g. So we're going to take x squared plus x, the g function, and place it into the f function. Now the f function says double the x value, but the x value now is replaced with all of this. So we're doubling all of that, and then we're adding 9 to it, plus 9. So notice, let me try to use different colors to emphasize this. All of this replaced just, all of that replaced just this x. So you take the entire g function and place it into the x, or the f function. And this should be fairly simple algebra now. 2x squared plus 2x plus 9. Okay, now this is a polynomial function. So polynomial functions always have all real numbers for the domain. So we're just going to type for the domain. Let's see here. Oops, not f. It's going to be negative infinity to positive infinity. Okay, now g of f of x. G of f of x would take the entire f function, which is 2x plus 9, and place it into the g function. So anywhere we see an x in the g function, we'll replace with this. So we're going to get, it was x squared, but now it's 2x plus 9 squared. And it was plus x, but now it's plus 2x plus 9. Now be careful, to do 2x plus 9 squared, you have to FOIL, and I don't need parentheses for the second one really because I'm not doing anything to it. If we FOIL this, first would be 4x squared, outer would be 9 plus times 2x, which is plus 18x, inner would be 9 times 2x, which is plus 18x, last would be 9 times 9, which is 81, plus the 2x plus the 9, plus 36x plus another 2x is 38x, plus 81 plus 9 is plus 90. So we would get 4x raised to the second plus 38x plus 90. And the domain, because this is a polynomial function, the domain is all real numbers. Just let me copy paste. Okay, spoiler alert, all these are polynomial functions, so they're all going to have the same domain. F of f, you're going to plug the function into itself. So the function with the function plugged in would look like 2, but x is now replaced with 2x plus 9 plus the original 9. So we get 4x plus 18, 4x plus 18 plus the 9 would be 4x plus 27. And g of g is going to be x squared, but it's now x squared plus x squared plus x, but x is really x squared plus x. And so we're going to FOIL this again and get x to the fourth plus 2x3 plus x squared plus x squared plus x. I went pretty fast with the FOIL there. You might want to write it out. I just did it in my head quick. And so we're going to get x4 plus 2x cubed plus there's actually 2x squareds there plus x. So we get x to the fourth plus 2x raised to the third plus 2x squared second plus x. And we've got nothing but green check marks on that one. Perfect. Okay, for problem 11. Okay, 11 is a word problem where a drawing would be good. So we have an airplane flying at a speed of 200 miles per hour at an altitude of 1 mile and passes directly over a radar station at time t equals 0. So we got a radar station down here, and the plane is right above it at time 0. So this distance here is 1 mile. And then this thing is traveling at 200 miles per hour. Okay, so the horizontal distance it travels is just 200 miles times however many hours you have. So it's just going to be 200 times t. Okay, express the distance between the plane and the radar station as a function of d. So this one's a little more interesting. So as this airplane gets further away from the radar station, this is going to form a right triangle. So here's the radar station. Now the airplane is over here. This is always 1 mile. So that's interesting. That's going to stay the same. This is a right angle because it's flying perfectly horizontal. This is 200 times whatever time you have. Then they're using S for the hypotenuse of this triangle. So S is going to be Pythagorean's theorem, which says it's going to be the square root of 1 squared plus 200t squared. And so that's going to equal, do these squares, you're going to get 1 plus 200 squared is 40,000 times squared. So as a function of d, let's see here, d of t is 200t, express distance s as a function of the distance d. Oh, so I guess they're calling this d. They're just saying this is d. So this is d squared. So we kind of did, we did this and we already got the third answer too. So let's just plug this in. This would just be the square root of 1, plus d raised to the second. Now in the second part, when you replace d with what it is, 200t, you get this would be 1 plus 40,000 times t time raised to the second. Okay, so that should be for those two. Okay, so a nice right triangle drawing with Pythagorean theorem is all I need for that. Okay, so for problem 12, they also want us to review composite functions. So we have two linear functions, and it wants to know, is f of g also linear? So we're going to actually solve the second part first, and then we'll answer the first part. So if f is m1x plus b1 and g is m2x plus b2, f of g would be take the g function and place it into the f function, which would be f when x is replaced with m2x plus b2. And when we replace the x of f with that, we would get f of g is equal to m1 times x, but x is now m2x plus b2 plus the original b1. And when you distribute this m1, you get m1 m2x plus m1 b2 plus b1. This is still linear. So this is now the constant that we used to call b, and all of this is now the slope. So this is the constant or the y-intercept. It's just a number. And now the slope is the previous two slopes combined. So we would say, is this linear? Yes, it sure is. And what is the slope of the new one? Now we got to be careful about this. How do we do subscripts here? m1 times m subscript 2. Okay, and that is problem 12.